Hello, Algebra 2 students. This is the third lesson in our discussion of factoring methods. And today we're going to be looking at factoring our trinomials when the a term is not equal to 1. Copy down the title as well as the objective. And our objective is: the student will learn the process and procedure for factoring quadratics when the a term is not equal to 1. Now, the second lesson that we went through, the title was Factoring when the a term is equal to 1, so quite obviously we saw plenty of problems where the a term was in fact equal to 1, meaning our trinomial started off with simply x squared plus or minus something to do with x to the first, and then plus or minus a constant. But of course, we are going to see trinomials, or not all trinomials in the world, have a terms that are 1. So let's take a look at what happens when a is not a 1. As always, press pause whenever you need more time and then hit play when you're ready to move forward. Okay. Now, as I said, it's entirely possible that our a term will not be a 1 as it was on our previous lesson. Now, it's easier when the a term is a 1, but if it is not a 1, like the trinomial that we're looking at now, 2x squared plus x minus 6, it doesn't get all that much more difficult, but there is an extra step that is involved. We have to think about this problem a little bit more differently, just simply because it can be factored in a bunch of other ways that we haven't considered yet. Okay, now the concept remains the same. We are still looking at a couple of things. We are going to find out what the product of our a times our c terms are, and we are going to identify what our b term equals. Well, in this case, our a times c is 2 times negative 6, and that is negative 12. Our b term is 1. Now, once again, okay, we're going to take our a times c, our product, and we're going to factor it as many ways as we can. As it turns out, negative 12 can be factored in 3 different ways. It can be factored into a 1 times a 12, a 2 times a 6, and a 3 times a 4. Okay, so there are the different ways that 12 can factor. And just like we did last time, we're going to examine these values to try to find a way that we can either add or subtract 2 of these terms so that they will equal a positive 1. Okay, well, now obviously over there on the right-hand side, if we were to have a negative 3 and a positive 4, when those guys are combined, that would be a positive 1. So those are going to be the factors that we're going to use. However, before we were able to jump straight to our factor, straight to our answer. Okay, we can't do that in this case because that will not give us the correct a term, correct coefficient for our b squared. Okay, so what we're going to do is this process when a is not equal to 1 is this is going to be information about the bx term. And we're going to split it into 2 new x terms that will have these values as their coefficients. Okay, so all we're doing is instead of having an x squared plus something to do with x plus something to do with a constant, now we're going to have 2 x terms. Okay, and we're going to build what is called in mathematics the box. Okay, as you've probably figured out here lately, several things are called the box. Okay, but here we're going to plug in on one of the diagonals in this box. We're going to put the ax squared term and the constant on one of the diagonals, exactly the way that they are written in the problem. However, we're going to dispose of the original x term, and we're going to write in these 2 new coefficients as coefficients of x. So we're going to have negative 3 x's, and then we're going to have positive 4 x's, and they go on this other diagonal together. Okay, so using the information from the problem and from our factorization that we just did, we have 2x squared and negative 6 on one of the diagonals together, and then on the other diagonal are our new x terms, negative 3x and positive 4x. Please notice that the original positive 1x is gone. However, if we were to combine these two x terms that are on the right diagonal together, you would see that they combine into 1x. So 1x may not be showing up, but he's actually still there. We've just split him into two new pieces. Now, here's what we're going to do with the box. Okay? We are going to factor across each row and also down each column. Okay, so that means we have four different instances that we have to factor. For example, we've got the top row, 2x squared and negative 3x. We're going to factor across that and see what those two terms have in common. Also, across the bottom row, the positive 4x and the negative 6. We're going to see what they have in common. Then we will do the same coming down the columns. Okay, so let's take a quick look at the top row, 2x squared and negative 3x. What do they have in common? They have an x. Okay, we may run into terms that do not have anything in common, in which case the greatest common factor would be a 1. But in this case, they do have something in common. They have an x in common. The bottom row, what do they have in common? Those are both factors of 2. We're going to be able to get a 2 out of those. Okay, coming down the left-hand column, we can get a 2 and an x. And coming down the right-hand column, we can get a negative 3. Okay, so what you do is you will write your factors, the things that the rows and the columns have in common, just kind of write them out to the side of the rows and the columns of the boxes. Now, one little side note, on the right-hand column, we factored out a negative 3. How will you know if you're going to factor out a negative or a positive? Well, obviously, in this case, both of the terms had a negative value, so it's very easy to know that you're going to factor out a negative since they both have that in common. However, the general rule of thumb for the box is that if the first term has a negative sign, then you are going to factor out a negative. So coming down that column, because the negative 3x was negative, we're going to get out the negative sign. Okay. Now we're going to take those factors that we just discovered, the x and the 2 coming from the rows, and the 2x and the negative 3 coming from the columns. We're going to assemble those as part of two different binomials, and they will actually become our answer. The 2x and the minus 3 and the x plus 2 go together. And just like before, if you were to distribute back across these two binomials, you will find that you will get your trinomial back. Our problem is solved. It has been factored. Now, I'm quite certain that's a little bit more than just a little confusing, so we'll take a look at another one. Let's see it. Okay, 4x squared minus 19x plus 12. This problem begins the same as our problems from the other day began. We will try to identify what is our A times C product and what is our B term. Okay, well, A times C, that is the 4 times 12. That is 48. And of course, our B term is negative 19. Now, our challenge is going to be to look at all the different ways that 48 can factor. And I'm going to go ahead and tell you that there are 5 of them. Okay. Now, there is 1 times 48, obviously. 48 is an even number, so it should be 2 times something. So it's 2 times 24. The way to see if something is divisible by 3 is to add the digits together and see if that number is divisible by 3. For example, if you're trying to see if 48 might divide evenly by 3, take the 4 and the 8 from 48 and add them together. 4 plus 8 is 12. Is 12 a number that is divisible by 3? Yes, it is. That means 48 is also divisible by 3. Turns out to be 3 times 16. Kind of a neat little trick. As it turns out, 48 is also divisible by 4. That would be 4 times 12. And then from your multiplication tables you had to memorize years ago, hopefully you know that 48 is also 6 times 8. You need to discover all of the factors because typically only one of these pairs is going to work out in such a way that you can add or subtract to equal 19. and hopefully scanning through the pairs, you can see very easily which of the pairs it is going to be. We're going to need the 3 and the 16, and we're going to need them both to be negative. Okay, so those are the values that we're going to use. These will become our new B terms. Okay, so taking our information to the box, on one diagonal we will put the A and the C term, that's 4x squared plus and positive 12, and on the other diagonal we will have a negative 3x and a negative 16x. From there, we will factor across the rows and down the columns to see what our terms may have in common. So let's take a look. Going across the top row, what will 4x squared and negative 3x have in common? Okay, well, they do have the x in common. One of them is positive and one of them is negative. Well, we want to try to factor out a negative. Well, remember what the rule was. If the first term coming across the rows or down the columns, if the first term is negative, then you factor out a negative. In this case, the first term is positive, so we will factor out a positive x. How about the bottom row? Coming across the bottom row, 12 and 16 are both contain factors of 4, so we can factor out a 4. And the first term is a negative value, negative 16x. So we will factor out a negative this time. So it'll be a negative 4. Now coming down the left-hand column, what do the 4x squared and the negative 16x have in common? They have a 4, and they also have an x. It will be positive this time because the first term was positive. And coming down the right-hand column, and we can get a 3 out of 3 and 12, and it will be negative because the first term is negative. So let's take a look. Okay, positive x and negative 4 coming out of the rows, 4x and negative 3 coming out of the columns. If you assemble this information into binomials, 4x minus 3 and x minus 4, that is the factorization of the trinomial that we were looking at. And of course, multiply it and check it to be sure. Okay, now I have a couple of problems that I would like you to practice in your notes there. So please copy them down and give them a few minutes of your time. The first trinomial will be 2x squared minus 4x plus 16. Remember, we're going to take the a times c, see what value that is, and recognize that our b term is the coefficient of the x. Factor your a times c in as many different ways as you can factor it, and then look for the terms that will add or subtract to equal your b term. Build your box, look for your factors across your rows and down your columns, and then build the binomials for your answers. One more question. 12x squared plus 5x minus 3. Also copy this one down and work it out. I appreciate you finding time to get your notes taken care of. This will end the audio, and I will see you in class.